This is my intermediate algebra course. Today we're going to continue to learn exponential equations and become more familiar with logarithms and logarithm notation. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. If you don't want to access your files, you can take a picture of these exponent rules with your phone. We're going to need those today. I know this is about the 16th time that you've seen those. You can take a screenshot also. Now in the previous class, we learned how to solve exponential equations like these, but with these problems, we're going to have to change bases on both sides of the equation. We want to get the same base on both sides, and we can't change base 8 to base 4, and we can't change base 4 to base 8. So we have to change both bases. I'm going to change 8 to 2 to the third power, and 4 to 2 to the second power. So I just changed this 8 to 2 to the third power and 4 to 2 to the second power. And now we're going to use rule number 5. We're raising a power to another power, so we just multiply the exponents. And I'm going to have to use distribution on the left side of the equation, so 3x plus 30 and 2 to the 6x. And now we're at that critical stage. The bases are the same, so we know that we can just get rid of the bases. Subtract 3x from both sides, divide both sides by 3, and we get x is equal to 10. So it's really the same type of problem that we were doing in the previous class. The only difference is we have to change bases on both sides of the equation. We may have done that 1 or 2 times in the last class, but most of them didn't require that. So first thing I'm going to do now is use rule number 8, which allows me to take that fraction and turn it into a power with a negative exponent. And I can't change base 25 to base 125, and I can't change base 125 to 25, base 25. So I'm going to change both bases to base 5. So now I'm raising powers to other powers, so rule 5 tells me that I can multiply the exponents. And I'm going to use distribution on the left side, so we get 8 minus 2x and negative 3x. So now we're at that critical stage, and we can get rid of the bases, so we're left with 8 minus 2x is equal to negative 3x. Put all the x's on one side and the 8 on the other side, and we get x is equal to negative 8. So it's really not that big of a deal. Same types of problems that we were doing in the previous class, except we have to change bases on both sides of the equation. So for number 3, I can't change. Well, let me start off by using rule number 9, because I'd like to, my computer will catch up. I'd like to change that to 27 to the 1/4 power. That's rule number 9. And then I'm going to change 27. I can't change base 27 to base 81, and I can't change base 81 to base 27. So I have to change both bases to base 3. So that becomes 3 to the third power, all raised to the 1/4, and 81 is 3 to the 4th power. And then I'm going to use rule number 5, raising a power to another power. We just multiply the exponents, and you can use dots or parentheses, whatever you want to do. And so now 3 times 1/4, that's just going to be 3 to the 3/4 power and 3 to the 4x. And now we're at the critical stage. So a lot of students get stuck with that, 3 times 1/4. This is just an arithmetic problem, but I'm going to review it just because a lot of students have problems with that. So 3 you can write as 3 over 1, and then it just becomes a fraction problem. You're multiplying fractions, so you just multiply the numerator and the denominator. 3 times 1 is 3, 1 times 4 is 4. Again, you should know that by now, but I'm just going to review that because a lot of students have trouble with those problems. So now we can get rid of those bases, and we're left with 3/4 is equal to 4x. Divide both sides by 4, and x is equal to 3 over 16. A lot of students have trouble with this step also. So you have 3/4, and we're dividing both sides by 4, so it's 3/4 divided by 4. That's what we're trying to calculate. And remember, when you're dealing with a fraction and a whole number, you can write the whole number as over 1. Then when you're dividing fractions, you just change to multiplication and flip the divisor, and it becomes a multiplication problem. 3 times 1 is 3, 4 times 4 is 16, 3 over 16, that's where we got that. So most intermediate algebra teachers would not show you that at this stage. They just expect you to know that. Okay, so I want you to try number 4. Remember, we have to change bases on both sides of the equation, and be sure to write all your Roman numerals and use number 1 to help you. So try number 4, use number 1 to help you if you get stuck, and when you come back, we'll do it together. All right, we're back. So I can't change base 9 to base 27, and I can't change base 27 to base 9, so I'm going to have to change both bases to base 3. So I changed the 9 to 3 squared, and I changed the 27 to 3 cubed. So now we're going to use Rule 5. Raising a power to another power, we just multiply the exponents. So we have 2 times 2x minus 5, and 3 to the 3 times x power. Use distribution on the left side of the equation, and we have 4x minus 10. And now we're at that critical step. We can get rid of the bases, so we have 4x minus 10 is equal to 3x. And we're left with x is equal to 10. All right, so I'm going to leave a little bit more space there. I had more space than I realized. So if you got that answer, good job. I want you to go ahead and try number 5. You can use number 2 to help you. And when you come back, we'll do it together. All right, we're back. So I'm going to start with rule number 8. Actually, no, I'm not. I'm going to just write that 1 over 16 as 1 over 4 to the second power. Then in the next step, I'm going to use rule number 8. I'm going to move these over a little bit though. So rule number 8 tells me that I can move that up to 4 to the negative 2 power. So we were at technically this could be considered base 16, but we already changed it to base 4. So I'm going to change that 64 to 4 to the third power. And then we're going to use rule number 5. To multiply those exponents. And we have 4 to the 3x minus 3. And now we're at the critical step. We can get rid of the bases, and we have negative 2 is equal to 3x minus 3. Let me find some more room. Okay, so now if we do the math on that, we get x is equal to 1/3. So if you got that answer, good job. Go ahead and try number 6. You can use number 3 to help you, and when you come back, we'll do it together. All right, we're back. So I can't, well, first of all, let's use rule number 9. So that root 8 becomes 8 to the 1/2 power. And I can't change base 32 to base 8, and I can't change base 8 to base 32. So I'm going to have to change both bases. So now we're going to use rule number 5 because we're raising a power to another power. And remember, when you're multiplying a fraction by a whole number, we went over that previously, so now we have 2 to the 20x is equal to 2 to the 3/2 power. And that's the critical step, critical stage. The bases are the same, so we can get rid of the bases. And this is the step that a lot of students have trouble with. You're going to divide both sides by 20, and you get 3 over 40. We went over how to do that on problem number 3. So if you got that answer, that's very, very good. Okay, let's go on to some next problems. That was equations in which 2 bases must be changed. 2 bases on either side of the equation. So at this point, we're just going to do some more complicated exponential equations, picking up where we left off in the previous class. We did these types of equations, but in the previous class, we would just see something like 3 times 2 to the x power plus 4 equals 28. So instead of saying something like this in yellow, we would see a simpler expression in blue. But now we're just going to have a slightly more complicated equation. It's not going to be very much, it's not going to be much more difficult, but this will review exponential equations, and we're going to use logarithms also in the next problems. So we have to isolate this exponential expression. It's not isolated because the 4 and the 3 are next to it. So I'm going to, I'm going to get rid of that 4, subtract 4 from both sides. And a lot of students, as I mentioned in the previous class, have trouble understanding that this expression here is multiplied by this expression. But that's the case. So if you want to get rid of that 3, you have to divide both sides by 3. And we end up with the following equation. And now we know what to do. Change that 8 to 2 to the 3rd power. And that's the critical step. We now have expressions where the bases are the same. So we can get rid of the bases. Now we have a simple 2-step equation we learned in pre-algebra. So x is equal to 4/5. So pretty easy on that one. Okay. So let's do one more of these, or not one more, but next problem here. So we have to get this expression by itself, and that's one of the simple exponential expressions we saw in the previous class. We're just doing this problem to review log notation. I'm gonna isolate this expression here by getting rid of the -9 and the 1. So I'm going to subtract 1 from both sides. Then that's 7 to the x divided by -9. So the opposite of division is multiplication. We have to multiply both sides by -9. Now, if this were a 1, then the answer would be obvious. We could just change the 1 to 7 to the 0 power, and obviously x would just be 0. If this were a 7, the answer would be obvious too, because we could just change that to 7 to the 1 power, and we could see that x is equal to 1. If this were 49, then we could change it to 7 to the 2nd power, and x would be equal to 2. If this number were 343, I know that's kind of a big number, but That would be 7 to the third power, and x would be equal to 3. But we don't have any of those numbers. We have 99. How in the world are we going to solve this equation? Well, we're not going to solve it. We can't do it. It takes upper mathematics that we've not learned at this level. So we have to use a calculator. But what do we enter into the calculator? Well, we enter log base 7 of 99. Remember, we learned how to do that in the previous class. So it depends on what calculator you're using, but if you're using an iPhone, put it in landscape mode, rotate it, push the second button at the upper left on the keyboard, push 99, then base Y at the middle, then 7, then equals. And they tell us in the instructions to round to the nearest 10,000th place. You see up here in purple, it says round to the nearest 10,000th. So the answer is approximately equal to, be sure to use squiggly lines, 2.3614. And we had to round down because the next number over was a 2. So tenths, hundredths, thousandths, 10,000ths, and the next number was 2, so we rounded down. If you want more practice on rounding, go to my arithmetic course. I have an entire class just on rounding. So this number is called an irrational number, meaning it's non-terminating, it never stops, and it's non-repeating, meaning there's no repeating pattern. That's called an irrational number. So a lot of students are very intimidated by this notation. They don't like it. They don't like it at all. But just be aware, it's just notation. That's it. It's just telling us how to enter in the number to our calculator. Because again, it takes advanced math to calculate what that x would be. So we just use our calculator at this level of math. Okay, so now we're going to do a problem just like number 8, but it's going to be a little bit more complicated because instead of just 7 to the x, we have 3 to the 2 minus 4x, 2 minus 4x instead of just an x. So this is going to be a little scary. So as usual, we're just going to isolate this exponential expression. We're going to add 57 to both sides. And then we're going to divide both sides by 8. And at this point, we want to know what do we raise 3 to, what power or exponent do we raise 3 to? 3 to what blue number is equal to 7? Well, again, if you're going to raise 3 to the x power, let's call it y. If you're going to raise 3 to some y power, some blue power, and it's going to equal, say, 3, well, that's easy because that would just be, y would just be 1. If you're going to raise it to, or if it's equal to 9, that would just be 3 squared. Y would be equal to 2. But the problem is we don't have 9 or 3, we have 7. So how in the world do we do this? Well, as I mentioned previously, we don't do it. We have to use a calculator. So we're going to have to use that logarithm notation. But because the blue power, you see how the blue is different over here. That's just an x. You see, whoops, let me highlight that other one. So this is just an x, but over here we don't just have an x, we have a 2 minus 4x. So instead of x equaling the log, we're going to have 2 minus 4x is equal to the log. So what is the base? Well, the base obviously is 3. The base is always the little subscript number. It's the little number that goes right next to the log, and then whatever's on the other side always goes there. All right, so we found what number we raise. This is the blue number that we raise 3 to get 7. So we did it. We found it. Problem is, we don't want that number. We want to know what x is. We don't want this number, that blue number up there. We don't want that number. that number is log base 3 of 7, but we don't want that number. We want to know what x is to get that number. What x do you plug in here to get this number that will give us 7 when we raise 3 to that number? So now what we have to do is we have to solve for x. So I'm going to subtract 2 from both sides. And it's very important to understand that you cannot combine this 2 and this 7. The 7 is inside the log function. You cannot subtract 2 from 7 and get 5. That's not allowed. So in the next step, I'm going to, need my x there. I'm going to divide both sides by -4. And so now all we have to do is use the calculator to approximate what this would be. I'm going to shrink this a little bit. So this is going to be a little scary putting this into the calculator because it really depends on what calculator you're using, and you need to enter it in the right order. There's a lot of room for error, so please be careful. There's a lot of different ways to do this, but I'm just going to use my iPhone landscape. Push the second button, push 7, then log base y at the middle, then 3, then equals. I just calculated log base 3 of 7. That's 1.771243, so on and so forth. Then I'm going to subtract 2, so -2 equals, and then divided by 4, and then the plus minus button at the upper right to change it to a -4, and then equals. So I know that seems like a lot, but as you get used to your calculator, you're going to get better and better at using that the log buttons on your calculator. 0.0572, so we have to round up on this one. 0.0572. Okay, so I know that seemed a little complicated, but that's why we're doing these problems. We're just doing exponential equations that are slightly more complicated. This problem here, again, was just to review how to use the log notation. Okay, so I want you to try number 10. You can use number 7 to help you, and when you come back, we'll do it together. All right, we're back. So I'm going to isolate this exponential expression. So I'm going to subtract 4 from both sides. And you can really do the first 2 steps at the same time. I'm just doing it one by one just to show you what's happening here. Divide both sides by 10. And I should have warned you, I guess, in this problem you are going to have to use an exponent rule. We didn't have to use exponent rules in these 3 problems up there. But we're going to have to use rule number 6. We're going to have to change that 5 to the first power. So I'm sorry I forgot to remind you of that. So you want to go back and write rule number 6 there. You want to keep track of the exponent rules you're using. That's this critical stage, so now we know that 1 is equal to 8 minus 4x. Get rid of the bases. And we end up with x is equal to 7/4. So if you got that answer, good job. You can just leave it as a fraction. Okay, so I want you to try number 11. Number 11 is going to require you to use a logarithm. So please use number 8 to help you. And when you come back, we'll do it together. All right, we're back. So I'm going to isolate the exponential expression. And I'm going to subtract 3 from both sides. So we get 32. Divide both sides by 4. And at this stage, we're stuck. We don't know what to raise 9 to get 8. We can't do it. So we have to use a calculator. But what do we enter into the calculator? Well, we enter log base 9 of 8. That's what we learned how to do in the previous class. And then we're going to go to the calculator. If you're using an iPhone landscape, and again, it just depends on what calculator you're using. If you're using the Android, it's going to be different. So plug in 8 log base y, then 9 equals, and rounding to the nearest 10,000th place, we get 0.9464. So if you got that answer, that's very good. So raising want to find x. X is equal to this here. So go ahead and try number 12. Use number 9 to help you. Remember, that's the tricky one where you have to solve for x. It's slightly more complicated, so try number 12. And when you come back, we'll do it together. All right, we're back. So I'm going to isolate this exponential expression. So I'm going to subtract 8 from both sides. And then I'm going to multiply both sides by -4. And at this point, we're stuck. We can't go any forward, any further. Because we don't know what to raise 7 to get to 40. 7 to the what blue power is equal to 40? Well, we don't know. We can't figure that out. So we have to use a calculator. But we know that that blue power, whatever it is, that blue power is going to be equal to log base 7 of 40. I know that's kind of complicated, but we don't know what that blue power is. We have to use the calculator to figure out what it is. I mean, think about it. What do you raise 7 to get 40? It's not easy to figure that out. But whatever the number is, the blue is going to be equal to that log base 7 of 40. Again, these are more complicated exponential equations. Now, before we actually use our calculator, we're going to go ahead and solve for x, because we don't want the blue power. We don't want that at all. We want x. What x do you plug in here to give you this log base 7 of 4? So we're going to solve for x, add 3 to both sides. So we have log base 7 of 40 plus 3. And remember, you cannot add 40 and 3. The 40 is inside the log function. Now we're going to divide both sides by -6. And we're going to have to get a little more room here. So remember, you have to be very careful about how you enter into this expression into your calculator. There's a lot of different ways to do it. So I'm going to push 40, then log base y. Remember to push the second button at the upper left on your iPhone. Then 7, then equals, then plus 3 equals, then divided by 6, plus minus sign at the upper right equals. Again, this is all for your iPhone. If you're using a different calculator, it's going to be different. It's going to be much different with an Android. So we get -0.81816. And that was a special case where this 10,000ths place became 0. So if you got that answer, good job. If you made a mistake, that's okay. Just go back and figure out what you did wrong. These are much more involved problems than we did in the previous class. Okay, so we're going to do a few more of these types of problems, just slightly different variations. So I'm going to solve this exponential equation by isolating that exponential expression. Subtract 8 from both sides. You get -9. And then we're going to divide both sides by -2. And we get 9 over 2 is equal to 4 to the x over 3 plus 5. And at this point, we want to know, what do we raise 4 to get 9/2? And that's obviously not a simple question. So we don't know. We don't know the answer. But we can use a calculator. We know that that blue power has to be equal to log base 4 of 9/2. Now, it's probably good to write that 9/2 in parentheses. Sometimes when this expression becomes complicated inside the logarithm, you need to be sure that people know what is in the log function and what's not in the log function. So we found the blue power. The blue power is going to be equal to this, whatever this ends up being in the calculator. But we don't want that. We don't want the blue power. We want x. So we're going to have to solve for x. So subtract 5 from both sides. And remember, you cannot combine 5 with the 9/2. You can't do that. The 9/2 is in the function. So just to be absolutely clear what's going on here, I'm going to go ahead and rewrite this. Usually we don't do this at this stage of math, but I want you to be absolutely clear what's going on. I'm going to multiply both sides by 3, and I have to multiply the whole side by 3. And because that's x over 3, so to cancel out those 3's, we're going to have to multiply by 3. We get x, and then we're going to have to use distribution. 3 times log base 4 of 9/2 is 3 log base 4 of 9/2. We just put the 3 right next to that. You see that? That means you're multiplying the 3 by the entire log. But again, you cannot multiply that 3 inside that log. It doesn't work that way. 3 times -5 is -15. So we use the distribution rule. Okay, and that's it. We're done. All we have to do now is just use our calculator. And again, I said it before, I'll say it again, there's a lot of room for error when it comes to entering this into your calculator. There's a lot of different ways to do it. So I'm going to enter 9 divided by 2 equals, and I get 4.5. Then I'm going to push the log Y button on my iPhone at the middle, then 4, then equals, then times 3 equals, then minus 15 equals. So we get negative 11.7451. And I know what you're thinking. You're thinking, I don't like having to press all those numbers in my calculator. Well, in the math curriculum, you need to know how to use your calculator. So you got to get used to it. You got to become more and more familiar with that calculator. And if you're having trouble with your calculator, don't get discouraged. You're going to become more and more familiar with that calculator as we go along. And you're going to start to become proud of yourself because you're going to learn how to use that thing. If you're having trouble with one calculator, then just find a different calculator. Remember, there's a calculator on your computer. If you have a computer. So I want you to try number 14. It's much like number 13. When you come back, we'll do it together. All right, we're back. So I'm going to isolate that exponential expression. So I'm going to add 14 to both sides. And I'm going to divide both sides by 6. And we don't really need the parentheses anymore, so we can just get rid of those. And so now I can't do this. It's impossible. We don't have the skills. We don't have the knowledge. So we have to use a calculator. So whatever that blue power is, it's going to be equal to log base 8 of 9 over 6, or 19 over 6. And please put parentheses around the 19 over 6 to avoid confusion. So if my computer will speed up there, we have this expression, but we found the blue power. The blue power is log base 8 of 19 over 6. But we don't want that blue power. We want x. So now we have to subtract 7 from both sides. And just to be absolutely clear what's happening here, I'm going to rewrite the equation and show exactly what I'm doing. I'm multiplying both sides by 5. Maybe I'll put a divider here. And remember, when you're multiplying a log by some number, you can just write the number right in front of the log. Five times 7 is 35. And so that's it. We're done. All you have to do now is just use your calculator to approximate the answer. So again, I'm using an iPhone. 19 divided by 6 equals log base Y button in the middle. Make sure to push the second button at the upper left on your iPhone if you don't see that log base Y button. So 19 divided by 6 equals log base y, then 8 equals, and that finds log base 8 of 19 over 6. Then you have to, keeping that number in your calculator, you push times 5 equals, then minus 35 equals. So we get negative 32.2284. So if you got that answer, that's very good. Good job. If you didn't get the answer, that's okay. Just figure out what you did wrong. Okay, so now we're going to do problems involving quadratic equations. So we're going to kill two birds with one stone. We're going to continue to learn exponential equations, but we're also going to review quadratic equations. So there's multiple ways to solve quadratic equations. We can use factoring, completing the square, the quadratic formula, but in these problems we're going to factor. So here we have a quadratic equation. How do I know that? Well, I have a variable squared, a variable times a number, and a number with no variable, and no other letters. So that means it's a quadratic equation. And we're going to solve this by factoring. It just so happens that this problem can be factored, or this expression can be factored. So we put two sets of parentheses, x and x, and we ask what two numbers multiply to 18 and add up to 11. What two numbers multiply to 18 and add up to 11? If you said 9 and 2, you're correct. So all we did was change this expression to this expression down here. Sorry, my computer's going kind of slow. We changed the blue expression to the yellow expression. Why do we do that? Well, now we can see the answers. Whatever you plug in there to make those parentheses 0, that's going to make the equation work. So obviously if we plug in x is equal to negative 9, that's going to make the factor at the left 0, and if we plug in negative 2, that's going to make the factor at the right 0. So the yellow times the blue has to be 0. If you plug in negative 9 into that yellow expression, you get 0. And if you plug in negative 2 to the blue expression, you get 0. That's why that works. So this is all just review. Some students may think, oh, I don't need to go over this. I already know this. Well, I know that, but we're just reviewing real quickly. So I want you to try example 2 just to make sure that you remember this. We've done this thousands of times, so go ahead and try example 2, and when you come back, we'll do it together. All right, we're back. So I'm going to write two sets of parentheses. What two numbers multiply to negative 8 and add up to negative 7? That's going to be negative 8 and 1. And so x is equal to 8, or x is equal to negative 1. You don't have to write those arrows if you don't want to. So if you got those answers, good job. Go ahead and try example number 3. When you come back, we'll do it together. All right, we're back. So we're going to solve this quadratic equation by factoring, because it just turns out that that expression is factorable. What two numbers multiply to 21 and add up to negative 10? That's going to be negative 7, negative 3. So x can be equal to positive 7, because if you plug in 7 there, you get 0. If you plug in 3, you get 0 also. So again, this is all just review. A lot of students don't really need to go over this again. Now, in this example, you see this coefficient here. Remember, that complicates things. That means that the two numbers, they're going to multiply to negative 2, but they're not necessarily going to add up to 1. So we have to write our two sets of parentheses, and we need to ask what two numbers multiply to 3x squared, and there's only really one option, 3x and x, and what two numbers multiply to negative 2, and there's only one option, -2 and positive 1. But we don't know if the -2 is going to go here or if it's going to go here. So we have to test this. And to test it, we use FOIL. F is 3x times x is 3x squared. O is 3x times 1. I is -2 times x. And L is -2 times 1. So F is first terms, O is outside terms, I is inside terms, and L is last terms. Then we combine these and we get x. And it looks like we did it correctly. I just chose those combinations randomly, and it looks like I got lucky. So now we know that one solution is 2/3. If we set this equal to 0, because that's what we want either the yellow to be 0 or the blue to be 0. If the yellow is 0, then you solve that and you get 2/3. If the blue is 0, then we get -1. So in some of these problems, you will see this type of situation where you have to factor, and one of the coefficients, or the coefficient of x squared, is something other than 1. So now we're going to solve equations that require quadratic, or that require us to solve a quadratic equation. So we're going to isolate this expression, just like we did in the previous problems. We're going to subtract 2 from both sides. And divide both sides by 3. And now we're going to have to use rule number 6. Remember rule number 6, that tells us that we can write 5 as 5 to the 1 power. And that's the critical stage because we see that they have the same base. So now we end up with -x squared plus 2x equals 1. We can get rid of those bases. And now here's a really, really critical stage. We must recognize this as a quadratic equation. We must. A lot of students will get to that point and they won't really recognize it as a quadratic equation. And if you don't know it's a quadratic equation, then you certainly can't solve it. See, that's the problem. Quadratic equations require special methods to solve, but if you don't even know if it's a quadratic equation, you're not going to solve it. I've got high school students and even college students that don't recognize that purple equation as a quadratic. Now, how do I know it's a quadratic? Well, as we talked about previously, I have a letter squared, a letter times a number, and a regular number, and no other letters, so it must be a quadratic. Problem is, we don't really recognize it as a quadratic. It doesn't look like anything familiar. But what if we put this -x squared on the other side and the 2x on the other side so that the left side is 0? Now do you recognize it? This is standard form. You cannot solve the purple equation unless you put it in standard form. So not only do you have to recognize it as a quadratic equation, but you also have to put it in standard form. If you don't do all of those things, then there's just no way that we're going to be able to solve this. So I'm going to highlight this, and I'm going to write standard form. You must put it in standard form. So now that it's in standard form, we can kind of see how to solve this. We can factor it. What two numbers multiply to 1 and add up to -2? Well, that's just going to be -1 and -1. So we see the solutions are x is equal to 1 or x is equal to 1. We don't really have to write it twice because it's just the same number. So we had, see the purple, we had to solve a quadratic equation. That's what's different about these problems. Now, are these problems very important in the general scheme of the mathematics curriculum? Not really. But there's a possibility that you may see them, and you need to branch out and expand your mind so you can be aware that some of these problems exist. Also, like I said, we're killing two birds with one stone. We're reviewing exponential equations and quadratic equations. So I want you to go ahead and try number 16. Remember, isolate this exponential expression. That's what we do in step number 1. And when you come back, we'll do it together. All right, we're back. So subtract 40 from both sides. And divide both sides by -2. And we can change 49 to 7 to the second power, and you can see where I'm going with this. Then we're at the critical stage. So we can get rid of the bases, and we have x squared plus x is equal to 2. And we must recognize that as a quadratic equation. If you don't recognize it as a quadratic equation, then you're just not going to be able to solve it, because quadratic equations require special methods. All right, so that is a quadratic equation. But not only do we have to recognize it as a quadratic, but we also have to put it in standard form. We can't solve it unless it's in standard form. So I'm going to put the 2 on the other side, and now it's in standard form. You see, so standard form, and now we can kind of recognize it, hopefully, so we can use factoring. What two numbers multiply to -2 and add up to 1? So that would be +2 and -1. So now we see that one solution is -2 and the other solution is 1. So if you got those answers, that's very good. Good job. I'm proud of you. Now if you made a mistake, that's okay. Just go back and figure out what you did wrong. Okay, so on to number 17. These are just more of these types of problems that require quadratic equations. So I'm going to use rule number 1. We're multiplying powers, so we just add the exponents. Then I'm going to change 64 to 4 to the third power. And you can see where I'm going with this. Now we're at the critical stage. The bases are the same, so that means the powers are the same. The exponents are the same. But it's very, very critical that we understand that's an or a quadratic equation. If my computer would speed up here, we could move on. So that's a quadratic equation. But we can't solve it. We can't do anything with it unless we put it in standard form. So now it's in standard form. And we then can hopefully recognize it. We recognize that type of equation. And we know we can solve by factoring. What two numbers multiply to -3 and add up to 2? Well, that's going to be +3 and -1. So that tells us that one solution is -3 and the other solution is 1. So let's try one more of those problems before you try one on your own. So now we're dividing powers. So rule number 2 tells us when you're dividing powers, you just subtract the exponents. And it's very important to understand that this only works if the bases are the same. You see how the bases are both 2? If they're not both 2, then you can't do that. So that's rule number 2. And now we're going to change 16 to 2 to the 4th power. And then we're going to use rule number 8 to bring that up to 2 to the negative 4th power. And you can see where I'm going here. We're at the critical step. The bases are the same. So now we have x squared minus 4x is equal to negative 4. Now, if you can't recognize that as a quadratic equation, then we're just dead in the water. We can't go anywhere. You must recognize it as a quadratic equation so that we can use our special methods to solve it. You must also recognize that we cannot solve a quadratic equation unless we put it in standard form, and also be aware that this coefficient here must be positive, or else it's going to be weird to have to solve that. So now let me find a little bit of room here. So this is now in standard form, and you don't have to write all these colors, and you don't have to identify it as a quadratic and all that. I'm just doing that for your benefit. So when you do the homework, don't worry about doing that. So we're going to factor to solve this, and what two numbers multiply to 4 and add up to negative 2? That's going to be negative 2 and negative 2. And so the two solutions are x is equal to, well, it's just going to be 2, so I don't have a lot of room, so I'm just going to leave it there. We don't really have to write it twice. Alright, so now it's time for you to try. I want you to try number 19. You can use number 17 to help you. And when you come back, we'll do it together. Alright, we're back. So we're multiplying powers. We're going to use rule number 1. The bases are the same, so we can do that. That means we're going to add the exponents. Then I'm going to change 9 to 3 to the 2nd power. And I'm going to use rule number 8 to bring that up to 3 to the negative 2 power. And now we're at the critical stage. The bases are the same, so we can get rid of those bases. So we have 3x plus x squared equals negative 2. And we must recognize that as a quadratic equation. But it's not enough just for us to recognize it as a quadratic. We also have to put it in standard form, or else we can't solve it. So we have to do two things. We have to rearrange these terms, because the squared term always comes first, and we have to put the 2 on the left side. So we have x squared plus 3x plus 2 equals 0. And we can solve that by factoring. And that is standard form. So what two numbers multiply to 2 and add up to 3? Well, that's going to be 1 and 2. So x must be equal to negative 1, or x can be equal to negative 2. If you got those answers, that's very good. Good job. Okay, try number 20. You can use 18 to help you, number 18. And when you come back, we'll do it together. All right, we're back. So we're going to use rule number 2. Because we're dividing powers, so we can subtract the exponents. And now we can change 7 to 7 to the 1st power. That is rule number 6. And that is the critical stage. The bases are the same, so we can get rid of those bases, and we have 1 is equal to 2x minus x squared. Now it's important to understand that we have a negative x squared. So that means we're going to have to put that x squared on the other side in order to make it easier for us to factor. You can factor it putting everything on the right side, but it's going to be much easier to do it on the left side. And you're going to have to put the 2x on the other side also. And that, of course, is standard form. So we have to recognize it as a quadratic equation, and we have to put the equation in standard form, or else we can't solve. So now we can solve by factoring. What two numbers multiply to 1 and add up to -2? I think we already had a problem like that. And so the answers are just going to be 1 or 1, and you don't have to write them twice. Okay, so if you got that answer, good job. Okay, on to number 21. So these problems are getting a little bit more involved. So if we look at this problem, and by the way, these problems require substitution. You're going to see why in a second. You don't have to use substitution, but it makes it 1,000 times easier to conceptualize. So when you look at this problem, we don't really know what to do to solve it. It doesn't look familiar at all. And the reason it doesn't look familiar is two reasons. Number one, obviously we've never done it before. And number two, the expression just doesn't look familiar. It looks complicated. So we're going to have to use a special method here. We're going to have to make it turn into a quadratic equation. And these problems, you don't really see them very often, but you do see them. And so I'm going to go ahead and show you this problem. This problem is kind of designed to intimidate you. So if you feel intimidated by this problem, that's what it's designed to do. It's not that hard, but when you see what's going to happen here, you're probably going to get a little angry that these textbooks make this type of problem. Because it's not really a very important problem, but it's just something to show you that there's a lot of different variations of these exponential equations out there. We're going to use rule number 5. I'm going to change that first exponential expression to 3 to the x raised to the 2 power. So that's all I did, was just change that first expression. I took this here and changed it to that. And that is rule number 5. Now, we've never done that before. We've never gone backwards like that, at least not that I remember. Now, isn't it true that if you raise a power to another power, you just multiply the exponents? So if you raise a power to another power, as we did here, then you can just convert that to this, multiplying the exponents. Isn't that true? Well, that's what we're doing. We're doing rule number 5. The only difference is we're going backwards. And at this point, you probably are thinking, well, why in the world did we do that? Well, notice that now we have these 3 to the x's here that are both the same, those yellow 3 to the x's. Well, what we're going to do is we're going to use substitution. We're going to let 3 to the x power equal y. So I just made up that variable y. You can use any variable. You can use capital A, capital B, capital C. Z is a common substitution variable. And now what I'm going to do is I'm going to plug in y wherever you see those 3 x's in the above equation. So see how I plugged in that yellow y there to that above equation? So just to be clear, I'm taking this equation and I'm rewriting it down there. So now I can get rid of those parentheses. You don't really have to write the parentheses. I just did that just to try to avoid any confusion. And at this point, do you recognize this? That should look very familiar. That's a quadratic equation in standard form. So that's a quadratic equation. So this equation up here is so complicated that we had to actually convert it to a quadratic equation. Now we're going to have to solve it with special methods. And once we find y, we're then going to use y to find x. And I know what you're saying. I know what you're thinking. You're thinking this is uncalled for. And a lot of students think that when they see a problem like this because, again, this problem is designed to intimidate you. That's why it is here. So we're going to solve that equation with factoring, just like we did in the previous problems. What two numbers multiply to 4 and add up to -5? Well, that's just going to be -1 and -4. So now that allows us to find y. We know y is equal to 1 or y is equal to 4. So we found the yellow y's, but we don't want y. We only used y to help us find x. So you see up here says y is equal to 3 to the x. Well, we're going to have to then plug that in down there. So instead of y, we're going to plug in 3 to the x. So y turned into 3 to the x. So now we can change, because again, we're looking for x, we're not looking for y. So we can change 1 to 3 to the 0 power, and then we can obviously see that x is equal to 0. So over here, what power do we raise 3 to get 4? The answer is we don't know. We can't do that. We have to use a calculator. In the equation at the left, we didn't need a calculator, but for this one we do. What do we enter into the calculator? Well, we enter in log base 3 of 4. And as usual, we want to approximate to the nearest 10,000th. So we're going to write 4 log base y button, and then 3 equals, and we get 1.2619. 1.2619. We had to round up on that one. So I know what you're thinking. You're thinking, that problem is too complicated and I don't like it. But just be aware that there's probably hundreds of these types of exponential equations. You're not required to know hundreds of problems. We're just doing, 4 or 5 different types of problems. As long as you know how to do those, then that's all you're expected to do, at least for this course. And for most courses, 99% of courses. Okay, so let's do number 22 together. So I'll do one more of these together before you try one on your own. So I'm going to change that expression to 6 to the x to the second power. And so now, do you see this 6 to the x is the same? And that was rule number 5 in reverse. So now I'm going to let 6 to the x power equal y. So we end up with 3 times y squared minus 4 times y minus 15. So I just plugged in y, substituted y for 6 to the x. And we don't really need those parentheses. You don't have to write those parentheses. I'm just showing you that again to help you know exactly what's happening here. So now at this point we have an equation, a quadratic equation, where we have a coefficient here. So we're going to have to deal with that. That makes factoring much more difficult. So we're first going to have to ask what two numbers multiply to 3, and that's obviously 3 times 1. Or we could say what two numbers multiply to 3y squared. Well, that's 3y and y. Then we ask what two numbers multiply to negative 15, and I'm going to try negative 5 and positive 3. We might have to switch these numbers. I'm not sure. So, as usual, you're going to ask what two numbers multiply to 15, negative 15, but they're not necessarily going to add up to negative 4 because this 3 here messes things up. Remember, we learned that in previous classes. So now I'm going to do FOIL. Remember the FOIL acronym to help us. 3y times y is 3y squared. 3y times 3 is 9y. Negative 5 times y is negative 5y. And negative 5 times 3 is negative 15. 9y minus 5y is 4y, but we don't want 4y. We want negative 4y. But it's good that we got the right number. all we have to do is change the signs, and that'll give us the right sign. So we're going to change that to positive 5 and change that to negative 3. So again, when you have that coefficient in front of the y squared, you just guess and check. So now we can see what y is. Y is equal to negative 5/3, but remember, y up there we see was just equal to 6 to the x. And let me identify this as a quadratic. That's a quadratic equation, and it's already in standard form. So y is 6 to the x, so we can just replace y with 6 to the x. And so now we just have to solve these equations. Now over here, you see we can't really figure that out without a calculator, so we're going to write x is equal to log base 6 of 3, and then we just use a calculator to approximate that answer. And we're going to write 3 log base y 6 equals, and we get 0.6131. Now over here, we're going to raise 6 to a number to get negative 5/3. We cannot raise positive 6 to some number to get a negative. It's impossible. And why is that? That may not be exactly obvious, but if x is a positive number, it's not going to give you a negative. If x is a fraction, positive fraction, it's not going to give you a negative. It's just going to give you like a root or something like that. If x is 0, that's going to give you positive 1. If x is 1, that's going to give you 6. And even if x is negative, if we plug in like a negative number, well, that's just going to end up being 1 over 6 to the third. That's not negative. So there is no x value you can plug in to make that negative 5/3. So we can just say that there's no solution to that equation. And we must write a slash through that equal sign. And we don't really have to do much else with that equation. Okay, so I want you to try number 23. You can use 21 to help you. And when you come back, we'll do it together. All right, we're back. So we're going to change to 9 to the x raised to the second power using rule number 5. And rule number 5 in reverse. And now we see we have 9 to the x's are the same in both those terms. And we're going to let 9 to the x power be y, and rewrite the equation and plug in y for 9 to the x. And again, you don't have to write that step with the parentheses if you don't want to. So we can get rid of those parentheses so the equation will be a little more familiar. And now we see we have a quadratic equation, and we can solve this quadratic equation by factoring. And what two numbers multiply to 45 and add up to negative 14? That's negative 5, negative 9. So now that tells us that one solution, or at least y, is equal to 9 or y is equal to 5. But remember, we don't want y. We're just using y to help us solve the problem. We want 9 to the x, or we want x. And so we know y is equal to 9 to the x, so we can plug in 9 to the x for y. And you can see that one of these problems we can solve without a calculator. If we rewrite 9 as 9 to the 1 power using rule number 6, we can see that x is equal to 1. over here we have to use a calculator. X is equal to log base 9 of 5, and we just use a calculator to estimate that number. So 5, and then log base y button, and then 9 equals, and we get 0.7325. 0.7325. So if you got those answers, that's very good. Okay, and we also have to recognize this as a quadratic. It's probably good to notate that. That's already in standard form. So for number 24, you want to use 22 to help you. So go ahead and try number 24, and when you come back, we'll do it together. All right, we're back. So we're going to use rule number 5 in the first step. Rule number 5 in reverse. So that 8 to the 2x is going to become 8 to the x raised to the 2, raised to the second power. And you see that these 8 to the x's are the same now. So now we're going to let 8 to the x be y. And we have 4y squared plus 4y minus 35 equals 0. And we can get rid of those parentheses. We don't really need those. And we see now that we have a quadratic equation, and it requires special methods to solve. We're going to factor, but this is going to be more difficult because we have a coefficient in front of the y squared term. So I think that may be 2y times 2y, but you could also try 4y times y. I'm going to try -7 and +5 to multiply to get -35. And now I have to use FOIL, but I only have to use the O and the I of FOIL. So outside's 10y, inside -14y. Add those together, you get -4y, but we don't want -4y, we want +4y. So I'm going to change the signs to +7 and -5. And so there you go. So that tells us what y is. So y is going to be equal to -7/2, or y is going to be equal to 5/2. And we want to now replace y with 8 to the x. We're not looking for y, we're looking for x. So 8 to the x is equal to -7/2, or 8 to the x is equal to +5/2. And you know that based on the logic we were talking about previously, we cannot raise a positive number to some power and get a negative number. It's not possible. But over here we can find that. That's going to be, we can't find it without a calculator though, so we're going to have to use log notation. So log base 8 of 5/2, and remember to put that fraction in parentheses. And so in the calculator we're going to enter 5 and then divided by 2 equals, and then log base y button, and then 8, and then equals. And we get 0.4406. So if you got that answer, good job. Okay, so on to the next problem here. In the previous problems we had to solve quadratic equations in the exponential equations, and we used the factoring method, but now we're going to use the quadratic formula because these quadratic expressions are not going to be easily factorable. So let's first review. Here's a quadratic equation, just like we solved before, but now we cannot factor this. If you try to factor that equation, you'll find that it's really not easy. So we're going to have to use the quadratic formula, letting a equal 5, b equal -3, and c equals -7. And the quadratic formula is up here. Remember, we learned that previously in this class, so we're just going to do a little review. If you have some formula, ax squared plus bx plus c equals 0, then the quadratic formula tells us that x is equal to that nasty looking expression there. Looks very complicated, but as we found in the previous classes, it's not so bad. So we're going to go ahead and rewrite that equation just so we know what we're using. So it's negative b plus or minus root b squared minus 4ac all over 2a. So all we have to do now is just plug in a, b, and c. So b is negative 3, so that becomes a double negative. We have to use parentheses. Now we're going to plug b in again. Be sure to use parentheses when you're scoring a negative. Minus 4 times a is 5, times c is negative 7. So there's a lot to plug in there. And students don't like using that formula because it looks really complicated, but it's not so bad when you get the hang of it. And so you can do all that stuff under the root in your head just to make this go faster, but I'm going to do it step by step. Negative 3 squared is 9. Negative 4 times 5 is negative 20. Negative 20 times negative 7 is positive 140. 2 times 5 is 10. So then we get root 149 over 10, and that's pretty much it. We can break that apart because there's two solutions, 3 plus root 149 over 10 and 3 minus root 149 over 10. There's two solutions, but we don't have time to break that into two parts and show both of those. Okay, so I want you to try example 6. See what you can do, and be aware, I'm going to just show you what the constants are. A is negative 6, B is 1 because there's nothing in front of that x, and C is equal to 3. And then you can just rewrite the quadratic equation you see over here in blue to show what tool you're using. So try our example 6, and when you come back, we'll do it together. All right, we're back. So we don't really have time to write that equation, so I'm just going to go ahead and start plugging in. So we have negative b plus or minus b squared minus 4 times a times c over 2 times a. And I'm going to show you that you can go ahead and simplify all that stuff inside the root in your head. So negative 4 times negative 6 is 24. 24 times 3 is that would be 72, and then 1 squared is 1. 72 plus 1 is 73. So 2 times negative 6 is negative 12. You see how fast you can do that if you do that part in the root in your head. Now you have two negatives here, and if you left it there, that's fine. But usually when you have two negatives there, you want to multiply both sides by a negative just to make that expression a little more simple. And because this is a plus or minus, when you multiply the numerator by a negative 1, it doesn't really change the plus or minus. Now, if that scared you, you don't have to worry about that right now, but you can just leave it in this form if you want to. But if you got that answer, good job. So that's how we use the quadratic formula. So we're just reviewing the quadratic formula there. So now we're going to have some problems. We're just going to do 4 more problems today. We're going to have some problems where you have to use a quadratic formula. So I'm going to solve this exponential equation, first isolating this expression. Subtract 8 from both sides. Divide both sides by 2. And I'm going to change that 32 to 2 to the 5th power. And you can see where I'm going with this. That's now the critical stage. The bases are the same. So we're going to get rid of the bases, and we have 5 is equal to x squared plus 5x. Now that's a quadratic equation. We must recognize that as a quadratic equation, or else we're not going to go very far. So what that means is we either have to solve by factoring, or by completing the square, or by using the quadratic formula. But before we do anything, we're going to have to put it in standard form. So now it's in standard form. And if you try to factor this, if you try to figure out what two numbers multiply to -5 and add up to +5, you're going to find that there's nothing that's really easy. There's no rational number, no easy number, that is, that you can find that will work. So we're going to have to use the quadratic formula. So x is equal to -b plus or minus root b squared minus 4ac all over 2a. And I'm not going to show you what a, b, and c is because I think you have that by now. So b is 5, and a is 1. That's the coefficient of x squared, and c is -5. And then a is 1. So now I'm going to simplify the root part in my head because it's going to make this go a lot faster. So -4 times 1 is -4, -4 times -5 is 20, 5 squared is 25, 20 plus 25 is 45. You see how fast that goes if you do that in your head? Now you don't have to do that in your head. You can, show the steps if you want to. You can refer back to this problem here if you want to show those steps. Example 5. Now, unfortunately, we can't leave root 45. We've got to factor it to 9 times 5, take the 9 out, it's a perfect square, and leave the 5 inside. Now, if you're rusty on how to do that, how to change this expression to this, then you can go back to my class on roots that we did earlier in this course. And that's pretty much it. You can break it up into 2 parts if you want, but we don't really need to. Okay, so on to number 26. Now, here's a problem where we have to change that expression to 8 to the x power raised to the 2. Remember, we just got done doing these a short while ago. We see the 8 to the x and the 8 to the x. The difference with this problem is we're going to have to use the quadratic formula. We're going to let 8 to the x equal y. And therefore we get, and I'm not going to write parentheses. I think you get the point by now. We're kind of running out of time. So we cannot factor this expression. So, and you can figure that out just by attempting to factor this. You'll see that we can't, it's not easy to factor this. So we can't use the factoring method. So we have to use the quadratic formula. And so we have -b plus or minus root b squared, and be sure to use parentheses with the negative when you're squaring it, minus 4 times a times c, all over 2 times a. And notice that we're using y instead of x because we're trying to find y first. So now a double negative becomes a positive, and I'm just going to do all the math in the root to save time in my head. -4 times 5 is -20. -20 times -3 is +60. -4 squared is 16. 60 plus 16 is 76. And 2 times 5 is 10. Normally what we would do is pull out a perfect square out of here, but in this case, we don't really need to waste time doing that because we're just going to use a calculator anyway. And remember, y is equal to 8 to the x. We found y, but we don't want y. We want x. So then we replace y with 8 to the x, and again, we can just keep it in this unsimplified form. And it's important to be aware that plus or minus means there's 2 solution. So we have 4 plus root 76 over 10, or we have 4 minus root 76 over 10. Now, this over here is impossible because 4 minus root 76, that's going to be a negative number. Now, how do I know that? Well, we know that root 81 is 9, and we know that root 64 is 8. So root 76 has to be between 8 and 9. So if you subtract something between 8 and 9 from 4, you get a negative. So that's impossible. We'll just put a slash through that. Another way to figure that out is if you try to find log base 8 of all that stuff, your calculator is gonna tell you that there's something wrong there. And we can do that later on. But first, let's find x. So we're going to write log base. We'll find x over here, that is. So log base 8 of 4 plus root 76 over 10. And you have to be very careful about how we enter this into our calculator. There's so many ways that you can do this incorrectly. So, and there's multiple ways to do this, but I'm going to plug in 76 and I'm going to push the square root button. Then I'm going to enter plus 4 equals, then divided by 10 equals. Then I'm going to push the second button, so we have a log y in the center of the calculator if you're using an iPhone in landscape mode. Then log y, then 8 equals. And then we get our answer. So the answer is approximately 0.1156. Now let's do that again, except let's do this over here with minus root 76. So I'm going to plug in 76 and then square root, and then I'm going to change it to a negative with the plus minus button at the upper right. Then plus 4 equals, divided by 10 equals, and I get a negative number. Now if I push log y and then 8 equals, the calculator says error. And the reason it's an error is because you cannot raise a positive base to some power and get a negative number. So that's impossible. Why don't you go ahead and get a screenshot of these pages. That'll help you with number 27 and number 28. So now go ahead and try number 27. And when you come back, we'll do it together. All right, we're back. We're using rule number 2. We're dividing powers, so we're going to subtract the exponents. And then we're going to change 125 to 5 to the third power, and that's the critical step. And then we can get rid of those bases. And at this point, we must recognize this as a quadratic. If you don't do that, if you don't recognize it as a quadratic, then we're dead in the water. We don't know what to do. But it's not enough just to recognize it as a quadratic. You also have to put it in standard form. So we're going to put that 3 on the other side. So you have 0 on one side. That's now in standard form. So standard form. And if you try to factor that, if you try to use the factoring method, you'll see that it doesn't really work. We can't factor it very easily, so we have to use the quadratic formula. So b squared minus 4ac over 2 times a. And I'm going to simplify the part in the root in my head again just to make things go faster because we're kind of running out of time. Negative 4 times 7 is negative 28. Negative 28 times negative 3 is 84, and then negative 2 squared is 4. 84 plus 4 is 88. 2 times 7 is 14. So again, you can do step by step if doing that in your head is kind of intimidating. So, but you'll get used to that as you go along. You'll want to do that more and more in your head. So 88 is 4 times 22. The 4 comes out as a 2. 22 stays in. Again, you can just use a factor tree if you're not sure about that. Now, notice that there are 2's in each term, so we can divide both sides by 2, and we get 1 plus or minus root 22 over 7. Everything is divided by 2. I'm sorry if I'm going a little fast, but the class is starting to get a little long here. So we don't want to go too long. So I want you to try number 28. This is going to be the last problem for today. And again, you can get a screenshot of these two if that helps you, or those problems up there. So try number 28, and when you come back, we'll do it together. All right, we're back. We're going to use rule number 5. And then we're going to let 7 to the x equal y, and then replace 7 to the x with y in the equation above. We don't really need to use the parentheses. Now, if you try to factor that, you're going to find that it's not easily factorable. And so we need to find y. Y is going to be equal to negative b plus or minus root b squared minus 4 times a, which is negative 1, times c, which is 2, over 2 times negative 1. So then, doing the part inside the root, we have negative 4 times negative 1, which is positive 4. 4 times 2 is 8. 8 plus 10 squared, so 10 squared is 100, and then we get 108. 2 times negative 1 is negative 2. All right. And 108 is 36 times 3. So again, you can use a factor tree if you're not sure about that. 36 square rooted is 6. And 3 stays inside. But notice that we have everything can be divided by 2. So if you divide everything by 2, we get negative 5 plus or minus 3 root 3 over negative 1. And it's probably better just to think of it as dividing. When you have a polynomial and you're dividing by a monomial, meaning the monomial being negative 2, you just divide each term. So divide negative 10 by negative 2 and divide this term by negative 2. And you end up with actually positive 5 plus or minus 3 root 3. So that's all you have to write there. But remember that we're not looking for y. We're looking for x. So y is equal to 7 to the x power. So plug in 7 to the x, where we have y. Then remember, plus or minus means that there's 2 solutions, or there might be 2 solutions, 5 plus 3 root 3, or 5 minus 3 root 3, or at least it tells us that y is equal to 2 things. So over here, x is going to be equal to log base 7 of 5 plus 3 root 3. It's not exactly obvious if that's going to be possible or not. We could figure it out by analyzing, but it's probably easiest just to enter it into the calculator and see if our answer is going to be an error. So x is equal to log base 7 of 5 minus 3 root 3, and we'll see if that logarithm is possible with our calculator. So let's start with the log at the left. I'm going to enter 3 and then push the square root button, times 3 equals plus 5 equals, and then the log y, and then 7 equals. So over here, our answer is definitely possible, 1.1933, because this is positive here, so that obviously is going to be feasible. But over here, let's see what this gives us. So I'm going to plug in 3 and then square root button, and then times 3 equals, and I'm going to push the plus minus button to change it to a negative, then plus 5 equals, and we see we have a negative number. So that's not going to work. If I push the log y button and then 7 equals, I get an error. So we can just slash that out. It's not equal to. Okay, so that was the class today. If you want to take screenshots of all the work that we did to help you with your homework or to study for tests, go ahead and do that now. Here's screenshot number 1 and screenshot number 2 and number 3, number 4, number 5, and number 6. But don't go before you get your homework. Let's take a look at the homework. Here's screenshot number 1 of the homework. And here's the answers for the homework. Screenshot number 2. So be sure to get that homework done, and I'll look forward to seeing you in the next class.